All right, so I think hopefully everyone can see I posted the agenda in the chat. We have basically two things we're going to do today. First, we have Manikya with us. He's a GSOC student that worked with us this summer to add tabular learning methods to FastAI. So he's going to give a demo of his work over the summer. And after that, Lorenz will show some of the codename faster AI high-level interfaces that are now part of the package. So I guess, Manika, do you want to start us off?
Yeah, sure. Let me just share my screen. 1 second. Hopefully the screen is visible.
Yeah.
Okay. Yeah. So to understand like what all has been done, we'll just quickly go through a end-to-end task and see the individual pieces in action. Right. So to start with, we need to get our data in a container. So the method to do that is table data set, and in table data set, we can just pass in any object which satisfies the tables.jl interface. So here we have just passed in a CSV file, but in case we had a Parquet file, we can also just pass that in and everything should work. So you are not really restricted to any kind of format. Everything should just work out if it's supposed to tables.jl interface, which most formats do. Right. So once you have your table data set, we'll have to split that to get the target column. So here, the task involves predicting a categorical column which contains salary data. So it basically has two classes. So yeah, it basically has two classes, making it a binary classification problem. And so we just pass in the target column here. And now what we'll do is create a learning method for this. So learning method contains all the information you need to kind of pre-process your data, and like you can even infer what kind of model would work best for that data. So to create a tabular learning method, you basically need an input block and an output block and the list of encodings to perform on those particular blocks. So the input block here for tabular is table row. Table row basically contains all the categorical columns and continuous columns, and the output block is label for handling the categorical variable, which is salary in this case. And we're just processing that and one hot encoding our target column. Right. So because this is a this is a classification task, we use label. But in case we wanted to do some kind of regression, we could have used a continuous block, which works similarly. Everything's the same. All we needed to was take out the classification block and plug in this continuous block. And yeah, everything is other than that is the same for both of these tasks. So the data block API lets us create these learning methods very easily in a plug and play kind of way. Right. So to get a quick summary of what is actually happening, and we can use the describe method function, and it shows you like a quick description of what exactly is happening and what encoding is being performed on which blocks and what the output, what kind of data you'll get after encoding it and all that stuff. So yeah, so that's what's happening here. Right. So once you have your learning method, we'll see how to use that to encode our data and then quickly create a model through that. So getObs, so we have a row of observation here. And if you wanted to encode that, you can just use the encode function using our learning method. And as you can see, the whole row has been encoded, and this is ready to go into our model to perform any kind of learning task, right? So we have a couple of categorical variables which have been label encoded, and then a few categorical data, categorical and continuous data, sorry. And then this is our target, which is just a binary thing which has been one hot encoded, right? So to get the model after this, we can just pass in the learning method. And if you don't, so by default, it just creates a model which would be applicable for the kind of method we have described. And in case you wanted to customize any part of it, you can also do that, as you can see. Right, so here we have just added a dropout layer because we felt that might be useful. So we can easily customize any component of the model. Right, so once you have your model, you can either create a learner manually, or if you wanted to work with the defaults, you can just use the method learner function, and it directly gets you a learner which has information about uh, the data which you want to use, and even pass in the batch size you want to use, the metrics, and any callbacks if that's required. And once you have a learner, you can just directly call the fit function on it to train it. And yeah, so in just a few short steps, you're able to do the tabular classification on this. Does anyone have any questions regarding anything?
Yeah, I had a couple. First of all, thank you for the presentation. This looks very promising. It's come a very long way. So kudos to you on that. Yeah. Could you possibly go to the top of the notebook?
Yeah.
Yeah. So I had a first simple, I don't know, like an API kind of thing, which is that probably table dataset should be tabular dataset. Just a very simple thing. I think it sort of goes a bit well, like nicely. Could you come down a bit? Oh, also, categorify might want to be categorical or something. It's tiny things, but just something to keep in mind.
Right. So are you referring to this part?
Yeah.
Right. So categorify is just a data augmentation which label encodes your categorical variables. So say you had like apple, bananas, and or mangoes. So if you categorified it, it would become 1, 2, and 3. So it basically assigns an integer to the categorical variables. As you can see in the encode function, right? So all of these are all categorical variables which have been made into numbers, and using these indexes, let's say, you can use these in embedding layers to get a embedding vector. So that's the purpose of categorify.
Yeah. I mean, I understood that. I was just commenting on the name, just so that it kind of flows well, but that's fine. I was wondering if it would be possible for us to sort of not have to use too many, I guess, FastAI specific functions, and rather try to get more generic ones out. I'm sure internally those functions are completely generic, but rather than saying, for example, FastAI.get call types, tables.jl already has a function that does this, which I'm assuming FastAI is forwarding to. So maybe just using
yes,
it
uses the schema, tables.jl schema underneath. Yes,
exactly. I mean, it would sort of flow, I think, a bit nicer. I think FastAI.get call types is perfect for demonstration purposes, but just so it's clear to the users what is happening internally, it might be a good idea to also have a bit more of a Julian API, just so that it's clear to the users that they have the option to mess with the tables directly, rather than assuming that you're only restricted to the FastAI ones, which
right. So how FastAI was designed to be is kind of like a layered API. So users are free to work at any level they want, really. So as Lawrence will show after this, the FastAI stuff that even provides a greater abstraction over all of this. So yeah, like people are free to work at any level, really.
Absolutely. And I appreciated that bit about FastAI to begin with, and that's kind of why I'm saying that that's kind of a strength of ours, to expose any level of abstraction that we can where users are comfortable. So and just so it can also make it clear to the users what is happening internally. It's general Julia style to actually have, for example, tables or schema there rather than get call types. We can have both, right? Like there's no restriction, but
Sure. Yeah.
as tables adds more stuff, I guess, on top of it, it would make it more obvious to users that they can also work at that level if they so wish, because tables.jl API itself isn't bad to begin with, right? And most of them aren't. For example, the category one, I believe there's an array type already available. I think it's pooled array or something. I forget the name, which does this exact same thing, right? So not that we have to use it, but just again, FastAI already works with those things, so it's better to also engage the users to know, that hey, you can just, if for whatever reason you want a different array type, maybe you want to name your dimensions or whatever, right? So just make sure that that is caught.
Yeah, I can just step in here. None of the get call types, get transform dict. First off, I guess these are some helper functions that Manikia created, working on this, but we haven't yet decided on what the FastAI API is going to look for that. So a lot of augmentations require kind of this metadata that comes from your data set. And obviously we don't want users to have to manually collect that information themselves. So we do want a higher level API. We haven't decided what that is. So likely the final function that people use will not be get transform dict or get call types. That being said, everything downstream, like the constructors for the models, or the augmentation functions and things like that, don't require that you use any of the FastAI functions. They, in the case of get call types, will just accept any vector or tuple or iterable. Most likely it's going to be a vector of symbols if you use some tables.jl interface, but there's no restrictions, I guess, in that sense. If a user wanted to manually write out what their call types, the output of get call types for customizability for some reason, they can already do that, and that's kind of how we've tried to design everything here. Yeah.
Yeah, and to that point, that's exactly what I'm saying, right? And I'm not trying to imply that we can't do that. What I'm trying to say is that it is important for us to make sure that we message that to the users as well, right? Because what we are dealing with internally is a very generic representation anyway. It's fairly easy for us to say, you want to mess with your data set using some kind of weird specific thing that is supposed to be used only with your file type or whatever. Like if it's a parquet or an arrow or whatever, you're free to do that. But here's a high level function where you can just give it anything and it will work for 90% of the cases. But we are flexible enough to just not care about whether you call a helper utility or whatever, right? I think that's a strength of the package more than anything. Like I wouldn't worry too much about this aspect too much. But of course, as we've discussed multiple times, we want to have an abstracted view into training a model. That's kind of our MO at some point. So it's cool that we can have a higher level API, higher abstracted API, but also say that we're still flexible enough to not be bound by it. Does that make sense?
Right. Let me just jump in here. So the purpose of this demo is, as I understand it, mostly to show off the range of the features that have been developed here. So yes, it is useful to know about the low-level API, and yes, we should have documentation about it. And also, yes, like they're not mutually exclusive. Like you can totally imagine some sort of tutorial that shows taking and choosing different pieces, working at different levels of abstraction in the same place. The purpose of this is to show off kind of a lot of the work Manikia has done at all levels of abstraction. And part of there's a bit of a, like in a more general sense, there's a bit of conflict here because like generally when we're coming from the Flex side of things, we expect to have good control. But almost all of the feedback we've had coming in, all of the interest we've had about FastAI is where is the high level stuff? Where are the blocks? How do I write this in as few lines as possible? Where is the stuff that you've already done for me so I don't have to write it myself? So in that sense, this is like having this kind of documentation is useful, and we haven't had it before. Currently, we have plenty of stuff which is like, okay, these are the more flexible abstractions that are lower level that you can manipulate however you want. But what we've been missing is this kind of higher level stuff, and especially the very high level stuff that Lorenz is doing with the FastAI right now. So yes, I take your point, but that's not really the intention of this particular demo.
Yeah, and that's perfectly fine. And I agree we need the higher level sort of demonstration as well. I think we're on the same page on that. So yeah.
Yeah, I just want to point out like the lower level stuff is like one is it's not being neglected, both the functionality and the documentation. And two, there is not really this hard of a delineation between different levels of abstraction as you'd see in something like FastAI Python proper, where I believe the lines are a bit, there's more division. Like there's my experience using it is that there's definitely friction trying to mix and match certain parts. Whereas here, a big part of the whole design was that we want to reduce that as much as possible. That doesn't mean there won't be any, but like that is an explicit design goal here.
I mean, yeah, that is kind of the intention of a Julian approach. So yeah. Would you mind scrolling this a little bit lower? Okay.
Sure. Yeah.
Yeah, I think just a little bit before this, just from training side of things, it would be nicer. I mean, I know that learners can actually not really worry about most of these arguments and so on, but it would be sweet to sort of not. I mean, for certain demos, especially the high level ones, we probably want to make it kind of terse, right? That's one of the things that we've been told fairly often, that we want the 5-level thing or 5 lines of code thing or whatever. So it might be sweet for us to whatever optional arguments that we do have, for example, 2 GPU training, so on, we can probably just not worry about it in this case. You can say that by default it's in training mode. Does that kind of make sense?
I think we should have both kinds of documentation, of course. So just to get started, the very high level 5-liners, which I'll get to in a minute, and then the more learning oriented tutorials where you maybe dive a bit deeper, or maybe to explain some of the additional customization you can make. You can have like a details box that you can pop up, so that it doesn't you don't need to read it. Keeps the rest of the tutorial short. I think it's really not a question of doing one or the other. Actually, why not just both? Of course, we need to write the documentation, but yeah. Of course, in this notebook, it was also about showing, that it's easy to customize how you can hack on it, and then it's not just opaque 5-liner.
Exactly. I mean, I think we're on the same page in that, because I completely agree that we want to show the 5-liner and not neglect the customization. I was just mentioning that might be a good thing for a specific 5-liner to not have to worry about too many details and so on, which can be in text, Yeah, I mean, I already know that these things are defaulted tools, so it makes sense. We can automate a lot of stuff, so it's fine.
Yeah,
Definitely.
and I just wanted to clarify that what we asked Manikia to show today was, I guess, this is more of a developer-oriented demo, right? To show off the breadth of what was done as part of the GSOC. But if for anyone watching, the actual, if you want tabular classification in 5 lines, that is there, but we're intentionally adding other stuff here because these community calls that we do are a little bit more developer oriented. But like Lorenz said, there'll be both flavors of tutorials on the actual documentation.
Yep. And again, Manikia, brilliant job on the GSOC. It looks very crisp and very neat.
Thank you. Yeah.
Yeah.
Does anyone have anything else to add? Otherwise, Lawrence, you can maybe go ahead with the FastAI stuff.
Yeah, welcome. Just turn on the screen sharing. Right, can you guys see my screen?
Yes.
Okay. So right now I want to give a quick preview of some of the high-level interfaces that I've been working on. A week ago, I published a little design document that goes through some of these, which you can find. Maybe someone can send a link. And the idea was, after the feedback we got 2 weeks ago, during the Q&A, to really make it easier to get closer to the 4-liners and FastAI, and to give a very high-level API that you can use and get started training models really easily. So the basic idea was to have 5 steps. You load the data, you define the learning task, and this includes how the data is pre-processed and decoded. Then you put it together in a learner. This constructs a model specific to the task, and creates the data loaders, and then you train it with just the regular fit1 cycle, or you could do the fine-tuning method. You can use a learning rate finder first, and then you can just simply plot some results. So that's kind of the idea. I wanted to run this earlier, but unfortunately I messed up my Jupyter installation today. But this is all working code. This is already implemented and merged into master. It's not released yet because there are some minor adjustments I want to make, and also the documentation needs to be updated still. But yeah, with this, I've tongue-in-cheek called it FastAI, because you can get started even faster. It's really built all around these blocks. If you're familiar with the data block API from FastAI. So here, these are all supervised tasks where you have an input block, an image, and then you want an output, which is a label for a single label classification. And then it's very similar for multi-label classification, for segmentation masks, same for key points. And then you just have some, these are just some wrappers around block methods. So in the notebook that Manikia showed, he used the block method directly, and where you specify all the encoding steps, and this is really just a small wrapper around that, so you can easily customize it. yeah, and then you can get from 0 to 100 in just 5 lines. That's pretty good. And but I was also thinking about how, and instead of just being able to copy an example like this, how can we really make the workflow easier? So I built this on top of the high-level function. I built this little demo, which is just a very simple web interface on top of the FastAI functions, where you can select an input block. Like it's just image for now because it's all I've gotten to implement, and target block. Then it will automatically show you all the data sets you have available for this combination. So it will show you the learning method wrapper. So what tasks you can do with this. So let's say I change this to label multi, then we have the Pascal data set here as a pre-configured recipe, and this is changed to image classification multi. You can also see that loads of different data set now, and each observation is an image and a list of labels. And we can look through, okay, bicycle in person, it looks about right. If we select the label, then of course there's only one category. So we have all these people holding their fishes and some dogs. This is the ImageNet data set. Yeah, for the mass, it's the same. For the Canva Tiny, we can scrub through, and looks like we're driving through the city. Very nice. And the mass are, of course, the labels for every pixel. And then just from that, you can actually, you've created the method and a data set, and you can create the learner and automatically fit. And the main idea behind this is, of course, that yes, it's easier to build a no-code front end, even a simple one like this, but also to help with discoverability. So there are really different resources and some APIs to access them. At the most basic level, you have these data sources. Right now, these are basically all data sets that are available in the FastAI dataset repository. So all the ones you can get in FastAI. Then you have, for every data set, you have some set of pre-configured recipes. And the important part here is that the recipes are dependent on what kind of task you want to solve. So here I'm looking for data sets that I have image inputs. I can restrict this to label multi, so multi-label data sets, and then here we have the Pascal data set. Yeah, so this is very flexible and just uses the types, and then we can pick a pair from here, the name of the recipe, and then just load it up. And dataset path, will download the dataset for you and just give you the path of the extracted archive as regular, and then it loads the data container. So this is what we saw above here. The same thing, and also the concrete blocks. So here it looks inside the image folders and actually gives you all the classes. So here with ImageNet naming, which is not the most intuitive, but yeah. Same, I could change this to mask, and so yeah. Where if I change this now, and this should also update. And now we have a mask here, and again, different classes. These are all the classes you have in the Canvas dataset. And then in the same vein, again, using the block information that you want to use, input block image, output block label. Okay, what can we use? What kind of learning methods? Okay, we have image classification single, and then we can look this up here. I hope I've already written the docs thing. Yeah, okay. So you can see here the arguments that it takes. And there's always a constructor that just takes the concrete blocks from here. But yeah, we can also customize it. So you can change the image size, pass in some augmentations, I get to how to customize the code in a little bit, but it makes it really easy to find functionality for the data that you have. So, for example, I can also change the target block to any, and now it'll show me all computer vision learning methods, basically. Okay, so we have segmentation, key point regression, and single label and multi-label classification. Yeah, that's actually okay. I have this one down here as well. Okay, so what are the benefits of this approach? There's a unified API. So every task that's in the library, you can use with just 5 lines. Then, as I said, it really aids in discoverability because you don't have to look through scout through the documentation for examples on a specific task or domain. If you know about that you want to do something with images, then you just plug it in here and see what you can do with it. You can find data sets for it. You can find the learning methods, which encapsulate all the task-specific functionality. It also means that third-party packages, which maybe have some very domain-specific functionality that is not integrated into the main package, they can contribute functionality because they can just register new data sets and new learning methods or new blocks also. And at the same time, I wanted to focus on that the code really remains customizable, and I show this here. So here we have all the five different lines, and then we have them kind of expanded. So instead of writing this, you could also write this, and then this gives you basically full control. So here we have this lower level load folder data, where we specify everything on how to load the data set. We can specify the blocks. So here we have this loads the image, this loads the target. Then we can get all the unique targets, put them into blocks. And then same, as I said, these learning method functions, they're just wrappers around block method. So this comes out to about the same. So here we can customize it, pass in some projections to this step in the pipeline. For the learner, I can also expand this. And now, of course, we could go even lower in the abstraction chain, but I just have this very high level and then slightly lower level. But of course, each of these steps, you can just replace them. And each of the 5 lines, you can customize one and you don't have to change the others. So if you want to do one cycle training, you can use the scheduler callback yourself. Yeah, so everything really remains customizable. Yeah. That's the new FastAI API. As I said, documentation still needs to be written. And yeah, then a new version will be released, but most of it is already implemented. And then it'll take some time before all the specific recipes for all the data sets are implemented. As you can see, there's quite a lot of data sets, but we want to get to a point where each one of these is really easy to use, and you can just write a 5-liner that uses it and trains the model to really good performance. Yeah. Are there any questions about this?
This looks really cool. Thank you. Thank you for the demo. This looks very neat.
I'm not seeing the chat. No. Okay.
We should probably also talk about adding distributed support to this. Once we have Flux doing that also, we can just have it automatically be triggered in FastAI.
Yeah. I mean, but I think that's a general thing. I mean, probably it would be, we can add it with a callback or model wrapper. I think, yeah, but
Yeah,
do
I
it in
think
a
for
way
the
that
most part,
the user doesn't have to do much,
yeah,
definitely.
yeah. For
But
the most
I
part, I
think,
think it's just going to be wrapping the model, and that's about it from
yeah,
the packages perspective. So we're good.
yeah. So yeah, I think most people won't have to do much to use that, and it also shouldn't be super hard to integrate with the way everything's built right now.
Yeah, this was a really cool demo. It's nice to see like I think everything really coming together. There's like a year of work behind all of this, so yeah, really nice to see. And I think yeah, I really like the point that because we committed to building all of this off of like lower level APIs, very generic lower level APIs in separate packages. You know, at some point someone could add something to any of those packages, whether it be augmentations, reading from different type of data sets on disk, you know, different data access patterns in like the loading pipeline, and those would kind of just automatically plug right into this entire flow without us needing to add much really or anything at all to the high level interfaces. So
Yeah. Yeah. So yeah, I think so too. I think, and yeah, as I said, each of the 5 lines in the example, you can swap them out independently, and you don't have to change anything else. So it's really easy to hack on some parts, because usually when I'm implementing a new paper or trying something, then there's usually only a small part of the pipeline that I want to change, and then I don't want to have to reconfigure everything else. So you just make the smallest change that you want to make, and then you should be able to reuse all the high level functionality. And then I mean, the selection, it looks a bit meager now, but it's really just a matter now of adding some of the implementations, basically. Same for the data set recipes.
I think
Sorry?
the message there is that we now have all of the infrastructure so that adding to these dropdowns is a relatively simple task now. We have everything in place. So yeah.
So if like anybody could now write a third-party package, just register some data sets for their domain and some blocks and a learning method, and then it would plug right in really without any problems.
yeah, I guess another cool thing is like this entire web GUI interface, you know, really
Yeah, I
is
mean,
just Pluto plus the high level interface
yeah,
plugged
I built
together
this
and
in
just
like
falls right out.
20 minutes. So it's a really, really light layer on top of the functions that I show here. Yeah.
Okay, well, if there's no more questions, I guess we don't need to go the full time today, but I just wanted to, you know, take a moment again to congratulate Manikya. He put in a lot of hard work this summer, and I think I can speak for Lance and Brian that it's been, you know, a pleasure working with him, and we hope he continues to contribute to our ecosystem.
Yep.
Yeah. Thanks again, Monika, for the demo.
Great
That's
work.
really cool.
Thanks, guys. Yeah, I mean, it's been a great summer, really. Learned a lot, and yeah, it's been really fun working on this. And yeah, I'll for sure continue contributing.
All right, cool. Well, thanks everyone for attending. Let me stop the recording.